welcome to my workshop. Today we're going to cut the second part out for Katie, the little CNC lathe, and we're going to make it out of this piece of 12mm thick aluminium, and it's 100mm or 4 inches. The total part is only going to take up 70mm, and that's the bracket that is going to connect to the ball nut for the Z axis. I've drawn the part up in ArtCAM Jewelsmith over there, and I'll just show you. So this is the bare piece of aluminium, and I'll run the tool paths. It's quite a simple part, really. And there it is. In actual fact, I'm going to have to modify this, because originally when I first drew this up, I was going to use 10mm plate, but I found a small offcut of 12mm, so that means I need to rerun the tool paths, which is very simply done. This is ArtCAM Jewelsmith 2012, and I've had this one since 2012, and of course subsequently, as ArtCAM has upgraded with newer versions, I've purchased the newer versions, and now of course ArtCAM has a new name, and that is Carveco. I will leave a link below this video so you can go and purchase Carveco yourself, because it's a damn good program. Okay, so we're going to tool paths, spot drill in, cut out, and we'll edit this one. Let's see what I've done here. Finish depth 10.5, and that should have been 12.5. I like to go through to the other side. What I do is I put a piece of wood underneath, or hardboard or something, and I cut through to that, so I get a nice clear cut. Apps 2, 12, 12mm thickness. Okay, it may do that. Calculate now. Okay, let's run that one. Okay, that's now gone all the way through the material, and it's as simple as that. So this is going to mount to the chassis block that I've made and mounted in the last video to the saddle of the lathe, and of course this bracket comes off the end of it, and this then gets bolted to the ball nut. These holes are strategically positioned because I have other drill-ins in through from the top, and obviously in through from this side as well of the main sort of chassis securing block. So before we can start doing a job, you need to home your machine. Now it's very simply done in Mark 3. Just press REFL. In Mark 3 you'll see that it's referenced now X, Y and Z in the machine coordinates. Okay, so I've put my piece of material on the bed now, and I've lined it up nice and square. But the last job that I used this for, which was machining that brass medallion, of course I've had the spindle set low down in its holding, so now I've got to raise it back up. So the first job I've got to do now is to set the X and Y 0 on this corner here, and then we'll set the Z with the setting tool. So let's jog over to this corner. And we get somewhere close. I've got plenty of material here. This is 100 millimeters wide, and we're only cutting an 80 millimeter piece, so I'll actually take it onto the material a bit. So we cover everything, and that's fine. So I'm going to set the X and Y 0 there, and you've all seen how I do that. So now we'll raise it up and move it onto the material here somewhere, and we'll use the Z height tool setter. And that goes something like this. And we're ready to go. Okay, so here we go for the spot drill. Okay, what I'm going to show you now, I don't see many people doing this on the internet. Actually, they don't show you these little things, and that is because the travel of this is 90 millimeter, which is just under 4 inches. So to get the reach of different tools, you need to alter the spindle in its housing, the length, and this is how you do it. You slacken off these bolts here, And a good little trick that I've learnt over the years, I've got one here somewhere. And that is, let me just move it over to one side. I'm going to show you a couple of little tips now about altering the spindle in its mounting. And one of the simple things is you get a odd piece of block of wood and you put underneath the tool. Don't put your fingers under the tool, because sometimes they can be unpredictable, and this can slide down, and this weighs about 8 kilos or more, and it'll go straight through your finger. So slacken these off. Okay. Now what I do is I put my hand underneath it there like that. Okay, so the chuck or the shaft is between those fingers. Okay, you just take the weight of it, get a screwdriver or something like that, just in here, and just wedge it open. A bit more. Sometimes it can be a little stubborn. Might be a little bit too. That's fine, because I got to take into consideration the retraction off this as well. So do it up at that, but notice, never get your fingers underneath it. Do them up firm, do these clamping bolts back up firm, but don't over tighten them, because the threads in here are going straight into the aluminium body, and you can strip them. I haven't done it, but I know people that have. Okay, so that tool, let's make sure that tool is tight. Sure it is. And that's a 6mm end mill in there, 2 flute. So we'll put the next code in, and off we go again. and this resulting mess is the only drawback of machining aluminium and certainly cutting parts out with a CNC router, because it's very fine small chips and it sprays it everywhere and it gets all over your machine. And I use WD-40 as a cutting agent. That's what you see me squirting on there. I also use air, because if you don't clean out the track when it's cutting it out, it'll just snap the tool off. And you'll also notice during the drilling process, I only had this running at 5,000 RPM, which is the lowest it'll actually cut, because you go lower than that and you don't have enough torque in the motor. These are sort of high revving and the torque band is quite up high, or say from 10,000 up. So and this is a 2.2 kilowatt spindle too. So do you think this looks anything like that? That's how to cut a piece of aluminium out. So and you know, this is as it comes off the machine. I have deburred the holes, but it's quite clean when it comes off. It's not bad at all, actually. I can just feel a little bit of an edge there, which I'll take off with a bit of paper, but pretty good. So I'll go and fit this on Katie now. There's no reason why it shouldn't fit. So I hope you've liked the video today. That's the second part completed and fitted and everything working pretty well, actually. Just a little bit of fettling to get it absolutely perfect. And at the end of the project of this entire build, I will put all the drawings in detail of all the specifications of all the parts that I've put into it, including the electronic parts, on my Patron pages. I would also like to take this opportunity to thank my patrons for assisting me, because without them this at this level wouldn't be possible, so thank you. So if you've liked this video, please like and subscribe to my channel. That's a big help too. And if you go along to my channel, you will find I've got 2 channels now. You'll find that there's over 350 videos now on CNC conversion, because I converted a mini mill too, and also later on this year I will ensure that I put all the detailed drawings and specifications up on the mini mill on my Patron pages too. So if you go along to my channel, you'll see that there's videos on converting, or how to convert machines to CNC. Also using the machinery to do jobs. Also you will see videos on CNC routing in great detail, of how to set the machines up and how to use those machines. Also laser, I do quite a bit of laser work now, and of course wood turning, which is one of my favorite things to do actually at this workshop. And I also do shop jobs as well that you know, people seem to like. You know, I make furniture and cabinets and benches, and it gives you an idea of maybe how you could go about making them. So thank you for joining me, and I hope to see you again. So it's bye for now.